In this video we're going to be looking at momentum and impulse. So the momentum of an object is the quantity defined as the product of the mass and the velocity of that object. So we can say that momentum equals mass times velocity. It therefore makes sense that the units that we use are kilogram meters per second. Let's have a quick look at the momentum of this lorry, for example. If it weighs 10,000 kilograms and is travelling at a speed of 14 meters per second, then its momentum equals 10,000 times 14. So its momentum is 140,000 kilogram meter per second. So the impulse of a force acting on an object for a given time is defined as the product of the force and the time acting on that object. So basically we can say the force times by the time equals the impulse. Therefore it makes sense again that the units for impulse are Newton seconds. Since we know that force is equal to mass times acceleration, and that the acceleration is the change in velocity divided by the time, we can also say that impulse equals mass times the change in velocity. Or since mass times velocity is the momentum, we can say that impulse equals the change in momentum. This is known as the impulse momentum principle. It's also worth noting that since we've been talking about acceleration, velocity and force, net force, that all of these are vector quantities. We may be asked to find the magnitude, which would mean we'd only need the size. However, these are fundamentally vector quantities. So a quick example here of finding the impulse. If we have a ball of mass 0.2 kilograms hitting a fixed vertical wall at right angles with an initial speed of 3.5 meters per second, and the ball rebounds with a speed of 2.5 meters per second, we can find the magnitude of the impulse exerted on the wall by the ball. So we know that its initial velocity is minus 3.5 meters per second, and that its final velocity is 2.5 meters per second. We have to say that they're they have the opposite signs because they're travelling in opposite directions. Therefore, we can calculate the impulse, which is the mass, which is 0.2, times the change in velocity. So the final velocity is 2.5. The initial velocity is negative 3.5. Therefore, the impulse is 0.2 times 6, which equals 1.2 Newton seconds. We can also use this relationship between impulse and momentum to calculate the speed after a force has acted on the object. So before we need to do that, we need to calculate the impulse. So a body of mass 2 kilograms is initially at rest on a smooth plane. A horizontal force of magnitude 4.5 newtons acts on the body for 6 seconds. Find the magnitude of the impulse given to the body by the force. So we know a force of magnitude 4.5 seconds acts on the body for 6 seconds. Therefore the impulse is equal to 6 times 4.5, which equals 27 Newton seconds. Given we know the impulse that's been given to the body, we can then work out the final velocity. So it's initially at rest, which means its initial velocity was 0. And the impulse given to the body of mass was 27 Newton seconds. So we know that impulse equals mass times the change in velocity. We know the impulse is 27 Newton seconds because we've just worked it out. We know the mass is 2 kilograms. We want to know what the final velocity is, and we know that the initial velocity was 0 meters per second. So that just simplifies down to 2v. Therefore, the final velocity was 13.5 meters per second.